Good morning, guys. It is Monday, April 20th, maybe? 19th? I don't know. Does it matter? Not really. All right, so this is, we're going to go through some more slides on the slideshow. Last week we talked about what the atmosphere is made of, the different gases and compounds. We also talked about the different things that are not gases that you would find in the atmosphere. Things like particulates, both solid and liquid, ash, pollution, ozone, mineral particles, pollen from plants, things like that. So we talked about what the atmosphere is made of. Now we're going to talk about the structure of the atmosphere. So the atmosphere is like a multi-layered cake. All right, so down here, this is ground level. We live in the layer called the troposphere. Right above that is something called the stratosphere. And as you can see in this diagram, the ozone layer is part of the stratosphere. It creates kind of a border between the stratosphere and the next layer up, which is called the mesosphere. And then at the very top, we have the thermosphere. And something to note about these different layers is they create what are called temperature inversions. So as you go up through the troposphere, the temperature, which is indicated by this red line here, the temperature decreases. Then you get to the stratosphere, and the temperature actually starts to increase again. That's because the ozone layer is absorbing a lot of that UV radiation, so it heats up the stratosphere layer. Then when you get to the mesosphere, the temperature drops substantially again. It goes actually all the way down to minus 80 Fahrenheit. And then once it gets up to the thermosphere, because it's just constantly being hit directly by all those cosmic rays, solar radiation, it goes way up again. All right, so the troposphere, as I said, it is the closest layer to Earth's surface. That is the air that we breathe in every day. That is what is composed mostly of nitrogen, with some oxygen and some argon and other things. This is where almost all weather occurs. So all thunderstorms, tornadoes, hurricanes, everything happens in the troposphere. And actually, if you look at a picture from space of a hurricane or a big thunderstorm, it actually flattens out and there's a barrier between the troposphere and the stratosphere, which is that next layer up, and it's because of that temperature inversion. Like I said, it's where all weather occurs, and it's where all the water vapor and carbon dioxide are found. So water vapor in the form of humidity and clouds, that's why all the weather happens here, and then CO2, carbon dioxide, that is mostly found in the troposphere as well, partly because it's sort of a natural byproduct of our living, plus all of the fossil fuels that we burn and things like that, pollution, etc. All right, the next layer up on our atmosphere cake is the stratosphere. It's the second layer up from the ground. It lies between the troposphere and the mesosphere. It's really important because it contains the ozone layer. Without the ozone layer, we would be a lot crispier. Unlike the troposphere, the temperature increases as you go up higher, which I mentioned on the previous slide in this diagram. Because it has that ozone layer, it's absorbing all that UV radiation, and so it warms up as you get up higher. So the stratosphere is the next layer up. It contains the ozone layer. That's the key takeaway. It has the ozone layer in it. If you get a chance to watch this video, this is incredibly cool. This guy's name is Felix Baumgartner. He has the world record for the highest skydive, and he actually goes up into the stratosphere using actually like a space capsule, and he has the world record for the highest skydive. In fact, there's at one point he starts spinning out of control and almost, if he hadn't been able to correct himself, he would have died. So there's so little breathable air up there that he had to wear a full spacesuit, which I think is pretty cool. Total badass. All right, the next two layers of our atmosphere cake is the mesosphere. There's not really much to know about the mesosphere other than that it's the coldest layer of the atmosphere. The temperature decreases the higher up you go. And then there's the thermosphere. That's the very top layer. That's sort of the icing on the cake. It's the uppermost layer of the atmosphere. It's the one that's furthest out in space. And this is where, if you've ever seen pictures of the aurora borealis or the northern lights, I think we've mentioned those in class before, this is where those take place, in this uppermost layer, in the thermosphere. And that's caused by a bunch of ionic material being hit. It's radiation from the sun. And all of those free electrons up in the thermosphere, they interact, and the byproduct is a pretty light show. So if you get a chance, definitely watch the What Causes Auroras video. It's only a couple minutes long, but it's very informative. I think it's pretty interesting. It's good stuff. Temperature inversions. This will be our last slide for today, because I feel like I've gone over a bit of material. I don't want to overwhelm you. A temperature inversion is anytime you have layers of warm air and cool air and warm air and cool air. So I mentioned temperature inversions. If I go back a few slides, this red line, as I mentioned, indicates temperature. So if you see how it goes back and forth, that means the temperature is decreasing, then increasing, then decreasing, then increasing. So those are all temperature inversions. It flips as soon as you get through the different layers. So that is a temperature inversion. Now these temperature inversions, they can lead to trapping polluted air at our surface, which is no good. An air pollutant is defined as any substance in the atmosphere that's harmful to people, plants, animals, or property. And certain weather conditions can make air pollution worse. So if you've ever been out driving around and you see those big lit up highway signs, there are certain days, especially in the summer, when it's really humid and there's not a whole lot of airflow, where you'll have air warnings, air quality warnings, and that's, you know, just saying there's a high level of pollution, it's not going anywhere anytime soon. So if you have breathing issues, if you're elderly, if you have asthma, maybe take precautions and don't go out during the hottest period of the day, or, you know, wear a mask or make sure you have your inhaler with you. All right, so that is the structure of the atmosphere. We'll talk more about pollution and things tomorrow. All right, take it easy, guys.